Average rate of change of a function. Recall the definition. Suppose f is a continuous function on the interval ab. Then the average rate of change from x equals a to x equals b is defined to be f of b minus f of a over b minus a. The average rate of change is also equal to the slope of the secant joining the points a comma f of a and b comma f of b. So if you're looking for this rate of change between this point and this point, draw a line, and the slope of that line is the average rate of change. Continuity of f on the interval ab is implied when calculating the average rate of change from x equals a to x equals b. Furthermore, the average rate of change can be computed even when the secant line passes through the function at other points. We refer to these points as incidental contact. So here, if we want the average rate of change between this point and this point, you can draw that line, and even though the graph passes through the line, it does not affect our calculation of the average rate of change. The average rate of change is equal to the slope of the secant joining the points a comma f of a and b comma f of b, and is given by f of b minus f of a over b minus a. What is the average rate of change of f on the interval -4, 1? At -4, we're down here at this point, and at 1, we're up here at this point. So we want to know the slope of this green line. So this is our point B, and this is our point A. F of B is 0, so we have 0, minus f of A, which is -7. So 0 minus -7 gives us +7, divided by B, which is the x value, 1, minus A, which is the x value, -4. 1 minus -4 gives us 5. So 7 divided by 5 gives us 1.4. If f is a continuous function on the interval a comma a plus h, then the slope of the secant from x equals a to x equals a plus h is given by f of a plus h minus f of a over h. This formula is sometimes called the difference quotient. A secant line intersects the curve g of x equals x squared plus 2x, where x equals 3 and x equals 3 plus h. Write the secant slope and then simplify the expression. So from the previous slide, we have our equation. All right, so f of a plus h. So we're going to have a of a plus h is 3 plus h, and a is 3. So we have g of 3 plus h minus g of 3 over h. So g of 3 plus h is 3 plus h squared plus 2 times 3 plus h, then minus g of 3, 3 squared plus 2 times 3 over h. So we multiply all of that out, combine like terms, and we have the h's cancel, and we are left with 8 plus h. That is the secant slope.